So diurnal motion is the daily rising and setting of the stars. So as Earth rotates, the stars appear to rise and set. And so they shift across the sky. As Earth rotates, it rotates about 15 degrees per hour, and so the sky looks like it shifts towards the west about 15 degrees every hour. Well, the other thing that happens is as Earth is rotating, it's also revolving around the sun, so it's orbiting the sun. And so every day the Earth is in a slightly different spot in its orbit, and so our view of the sky changes a little bit from night to night. And so this gives rise to the annual motion that happened in the sky. And this is something the ancients noticed. They saw that the sky repeated every night, but it was a little bit different. But after a while, it was back to the same spot again. So this is one way of they figured out how long a year was how long it took the sky to get back to the way that it was. And this is what we call annual motion. And that's because Earth is going around the sun. And so during part of the year, you look overhead and you see some stars. And during a different part of the year, at the same time of night, you look overhead, see different stars. And then different time of the year, you look overhead and see, at the same time of night and see even different stars. So Earth goes around the sun. Now, this has an interesting effect in that you see some of the stars that tonight are going to be overhead. You know, you go out at 10 o'clock and other stars overhead at midnight, but those stars will be overhead at 10 o'clock in a couple weeks or so. And so, or in a month or so. So so the sky shifts a little bit just because Earth is moving. It has an interesting thing. Imagine that you've got a giant dimmer switch on the sun. And so in Texas, that'd be fantastic in these hot summer days where it gets up to 100 degrees. But imagine that during part of the year, the Earth is in one location around the sun, and if you had a dimmer switch on the sun, it would look like it's sitting in front of a constellation. There'd be stars up. And the stars up in the daytime, you just can't see them because the sun's up. Now, a few months later, Earth has moved to a different spot, and then if you look at the sun, though, it looks like it's sitting in front of a different constellation. A few months later, Earth moves to an even different spot, and the sun, if you look at it, looks like it's in front of an even different constellation. And so this goes on over the course of the year. Eventually, Earth gets back to a starting point, and the sun looks like it's back in front of the same constellation it was to begin with. Now, in the ancient world, they didn't realize that Earth was the one that was moving. It just looked like the sun was shifting around the sky. And so they came up with a term for that. The apparent path of the sun through the sky over the course of a year is called the ecliptic. The constellations the sun appears to pass through over the course of the year is known as the zodiac. So the zodiacal constellations are the constellations that the sun passes through over the course of a year. And so that turns out to be an interesting thing, because it turns out that not only does the Earth go around the sun, all the other planets go around the sun, and the orbits of those planets and the orbit of the moon around the Earth are all kind of close, within a few degrees of the same plane. And so that means that not only do you find the sun in the zodiacal constellations, but this is where you would generally want to look if you wanted to see planets or the moon. So that means these handful of constellations, a couple handfuls of constellations, turn out to be very commonly utilized by astronomers. If you were to take a map of the sky and plot the position of the sun on it, the ecliptic would make this big arching path here around the sky. Okay, so you've got this big arching path right here that goes all the way around the sky. That's the ecliptic, and you notice that it actually gets only so far north and only so far south. The farthest north the sun ever gets is 23.5 degrees north, and the farthest south it ever gets is 23.5 degrees south, or minus 23.5 degrees. Okay, now that's an interesting thing, because what is directly overhead for us in the Fort Worth area? Well, it's close to 33 degrees, between 32 and 33 degrees. But the farthest sun ever gets is 23.5 degrees. So that means the sun is never directly overhead for us. Now, that's really kind of something that I noticed as a kid, because I was going to do a science fair project in elementary school, and I was going to have a stick, and I knew, because the teacher told me that at noon the sun's going to be straight overhead, and so I thought, well, that means the sunlight would come straight down, and there'd be no shadow on the stick. And so I did my little experiment to show that there's no shadow on the stick at noon, and guess what? There was a shadow at noon, and what even was more confusing to me was the shadow was actually shortest, not at noon, but, like an hour or so later. And so I was just really confused by that. And so I thought maybe I just didn't have the stick right, and so I borrowed my dad's level and made sure it was really vertical, and the experiment repeated just like it did before. There's still a shadow at noon. And so I was just like, oh, okay. Where would you have to be for the shadow to be non-existent at noon? You'd have to be directly under where the sun is directly overhead. And so now that means you have to be between 23.5 degrees north and 23.5 degrees south. So the farthest north you can be is 23.5 degrees north latitude. We call that the Tropic of Cancer. And the farthest south you can ever be is 23.5 degrees south, the Tropic of Capricorn. If you're between the tropics, the sun will be overhead. Well, how often? Okay. Well, if you had to be in Mexico City, which is about here, notice the sun is actually only overhead 2 days out of the year. So, yeah, it's in the tropics, but only 2 days out of the year. For part of the year, it passes north of overhead, and for most of the year, it passes south of overhead. Only 2 days is it overhead. Well, how often is the sun overhead of the equator? Okay. Well, again, my teacher told me the sun's always overhead the equator, but if you look at this, the sun's on the celestial equator, again, only 2 days out of the year. So only 2 days out of the year is the sun directly overhead of the equator. Half the year it's north of overhead, and half the year it's south of overhead. Another way of thinking about this is on the celestial sphere, you can plot the path of the sun here, and it makes this path that goes north and south, so it makes this big tilted path around. Okay, well, when it's north, notice it shines more on the northern part of the Earth. When it's to the south, it shines more on the southern part of the Earth. Now, that's actually what gives rise to the seasons, okay? And that's because of how this works. But before we get to that point, let me explain a couple of terms that are in this diagram. We have the farthest north the sun ever gets. We call that the summer solstice. The winter solstice is the farthest south the sun ever gets. The equinoxes are when the sun's on the celestial equator. The autumnal equinox happens in September when the sun's directly over the Earth's equator and it's on the celestial equator. The vernal equinox, that's in the spring, that occurs in March. And so this gives rise to what's going on here. But wait a minute. Is the sun really moving? No. It's really Earth that's moving. And so it's really Earth going around the sun, and Earth is tilted on its axis as it goes around the sun. It's tilted 23.5 degrees. So when Earth is in this configuration, then the sun shines mainly on the southern part of the Earth, and so the days are long in the south and they're short in the northern hemisphere. It's summertime in the southern hemisphere, and it's wintertime in the northern hemisphere. On the other hand, when the Earth is over here, then what happens is the sun shines more in the northern hemisphere. In fact, at the North Pole, because you're tilted towards the sun never sets. So you got like 6 months of light. On the other side over here, you're tilted away from the sun, and so you have 6 months of darkness. And so that happens at both poles. So in this case, though, you have the northern hemisphere having summertime, the southern hemisphere has wintertime. Okay, so the seasons are backwards because of this. And that turns out to be kind of an interesting thing. You know, for example, wintertime in the northern hemisphere over here, we have wintertime in the northern hemisphere, but it's summertime in the southern hemisphere. So that means that in December 21st or thereabouts is when the winter solstice is. And so that's the farthest south the sun ever gets, and so that's why it's actually cold in the northern hemisphere, is that you don't get as much sunlight, but you get more sunlight in the southern hemisphere. So that means that just a few days later, when Santa Claus delivers presents, he wears shorts and a tank top to deliver presents in Australia. I've seen pictures of that. Okay, so anyway, but that's due to the tilt of the Earth. Okay, this tilt of the Earth means that the sun sometimes is on the celestial equator, and sometimes it's north of the celestial equator, sometimes south of the celestial equator. Well, the celestial equator crosses your horizon due east, and it crosses your horizon due west. So in the summertime, when the sun is north of the celestial equator, it actually rises in the northeast and sets in the northwest. In the wintertime, it rises in the southeast and it sets in the southwest. By the way, remember, we got the zenith here, 33 degrees south, another 23.5 degrees to get down to the winter solstice. That means the sun is actually very low in the southern sky at noon. So 23 plus 33, that's going to be 56. So about 56.5 degrees from directly overhead. And so that means just a little over 33 degrees above the southern horizon. Again, that means the sun shines on the southern face of buildings more directly, whereas in the summertime, you actually get a little sunlight at sunrise and sunset on the northern face of a building. And so, again, this has to do with this motion here. And so you can sometimes notice that the sun shines in windows differently at different times of the year. And this is because of the tilt of the Earth and the motion of the Earth around the sun, this annual motion. Here's actually a picture I found on the internet, and it shows the sun from one particular location on Earth rising on different months, and so you can see that it sometimes rises to the north and it sometimes rises to the south. So again, this is at sunrise. And the sunrise is at different times. Now, this is actually something that's useful. In the ancient world, they actually aligned buildings with this so that on critical holy days of the year, the sun would shine through a building and illuminate certain things, like an idol or something, or a symbol or whatever, on a particular day of the year. And so, again, the ancients realized this annual motion here.